Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Our discussion today is going to be basically a discussion on the group 5 elements, and those are elements of nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. And basically, we are going to limit ourselves to the first 5 members of this specific group. Now, in our last discussion, we have discussed the range of elements from group 1 to group 4. And we had said that basically we are going to see some of the characteristics vary according to various groups of these specific elements. For instance, for the first two, which are group 1 and group 2, of course, basically this formed a range of metals for the alkali metals and alkaline earth metals in that specific case. And of course, this middle section of the group D elements, this is going to form a range of what we call a transition element, whose group is basically a group of metals. But as we go towards the right section of the periodic table from this specific group 3, we're going to see that there's going to be a variation of especially the metallic character, which is basically going to be increasing as we go from up parts of our upper members or the lower members in terms of atomic number to the higher members in this specific case. And there are some cases where we are going to encounter some members like silicon, germanium, arsenic, and antimony, and of course tellurium, exploiting this specific or exhibiting this specific aspect of semiconductivity, and therefore they are going to be classified as metalloids. Now, in this section for the group 5 elements, we are going to see that the first two members of nitrogen and phosphorus are going to be non-metallic in character. And of course, for the arsenic and antimony, they are going to display these metalloid characteristics of having the physical and chemical characteristics in between metals and non-metals. And of course, for the case of metals, we're going to see that bismuth is basically going to exhibit a metallic character. Now, this is going to give them a wide range of characteristics. And of course, we are going to see that in terms of other aspects which we have looked at for various other elements, these are also going to be displaying individual characteristics, which we are going to see later in some of our discussions. Now, in this case, I'm going to have a second illustration of perhaps the physical characteristic in terms of a tabular form. And that is going to give us a clue on some of how some of these members are going to be behaving as we go ahead in our next discussion. So the illustration I've given on the board is, of course, an illustration of the group 5 elements. And these are the elements of nitrogen, phosphorus, arsenic, antimony, and bismuth, which have been given in this specific order. Now, if we look at the section for the ionic or the covalent radii, of course, I've mentioned the difference between covalent radii, ionic, and atomic radii. This is going to be giving this particular trend of increase in terms of the covalent radii. And this, of course, is due to the increase in energy levels, which we had mentioned. Now, the concept of electronegativity, which is the ability to attract an electron, is going to be also decreasing in this specific order. And this, of course, is due to the increase, of course, in terms of metallic character, which we had mentioned. And therefore, it's also going to be due to the aspect of these specific elements. So we had said the first two elements for this specific case are going to be non-metallic, while arsenic and antimony are going to be metalloids, and bismuth is going to be a metal. So the increase in metallic character is going to be having an effect in this particular case. Now, for ionization energy as well, this is going to be decreasing due to increase in the number of energy levels. Now, in physical forms, nitrogen is going to be gaseous in form, while the rest of the members from phosphorus downwards is going to be exhibiting this specific characteristic for solids. Now, phosphorus is going to be a white and red solid. And of course, we're going to see that arsenic is going to be yellow-gray solid with a metal luster, and antimony is going to be a yellow silvery white solid, while bismuth is going to be a pinkish white metal solid, given in terms of that specific order. Now, the density of these various specific elements is going to increase, and we have said that the increase in density is due to the increase in mass and volume ratio. And therefore, that's going to be given in that specific order, an increase in density from this specific range of nitrogen, phosphorus, arsenic, antimony, and bismuth, given in that specific case. Now, the conductivity as well as we are going to see is going to vary, but not in a defined way. And these are some of the characteristics which we are going to see being displayed by some of these particular elements. Now, in our next discussion, we're going to look at just a summary of some of the perhaps chemical properties which we're going to witness for the group 5 elements. And that's going to give us a clue on some of the characteristics which we're going to come across in their various reactions and applications in our day-to-day lives. Now, from our previous illustration, I have said that basically this group of elements are going to consist of nitrogen, phosphorus, and then we're going to have arsenic, antimony, and then we are going to have bismuth. And these are going to be a range of a group, excluding moscovium, which I mentioned basically that we're going to limit ourselves to the first 5 members of this particular group. So I said that the first 2 members of this specific groups are going to be non-metals. And we have shown from our illustration the different physical characteristics and even in terms of colors how these members are going to be appearing. So the next 2 members are going to be under the class of metalloids, which basically means that they are going to exhibit some of the characteristics belonging to metals and non-metals. Now the last one is going to be a metal, basically, which is a member of a bismuth. And therefore, we are going to see that these are some of the properties, the unique properties which we are going to see being displayed by group 5 elements. Now, for arsenic and antimony, as I've said, of course, these are going to be metalloids. But if we try to look at phosphorus, antimony, and bismuth, these are going to exploit or display what we call allotropy. So I talked about the allotropes of carbon, and therefore these are also going to exploit display the concept of allotropy in some of their physical forms. So in case we come across them, I'm going to be mentioning about some of these. So I've mentioned the concept of red and white phosphorus, and therefore that's one of the aspects which we're going to come across in some of physical forms of these specific elements. Now the oxides so we have said these ones are going to be having these characteristics. So we have said the oxides of nitrogen and phosphorus. So we can just give an example of this. So we're going to have this oxide of nitrogen and of course this oxide of phosphorus. So this is going to be free form. These are going to be displaying acidic characteristics when they are going to react with water. So these are going to be acidic when they are going to react with water, and this is going to be a unique characteristic being given by these specific elements. Whereas the oxides of this arsenic and antimony are going to be amphoteric. So they are going to display both the acidic and the basic properties for the 2 specific elements. Whereas the first 2, the oxides of the first 2 are going to be acidic whenever they are going to react with water. Now bismuth oxide is going to be basic in nature. So therefore this is going to be a basic oxide. The 2 are going to display amphoteric oxides. So this is going to be amphoteric, which means they are going to have acidic and basic properties, where the first ones are going to be acidic in nature in water. So therefore those are some of the general characteristics of these specific chemical properties of these oxides of these specific elements. And of course, we're going to see that in terms of distribution, the particular elements are going to be occurring in particular quantities in nature. And of course, we're going to see that nitrogen as an element is going to be occurring in the atmosphere as part of the composition of air. But in some forms, we're going to see that unlike other group of elements which we have discussed for the first one, the second, or group 1, 2, 3, and 4, we're going to see that some of them are going to be found in even animal proteins, unlike the first cases which we have discussed for the availability or abundance in the earth as crust. So therefore, if you look at this nitrogen as a molecular, of course, a compound, or a molecular structure, or a molecular form which is going to be found in the atmosphere. So this is one of the sources of this specific element of nitrogen, which is going to be found as a diatomic molecule in the atmosphere. So this is going to form a 0 point, also 0 point in terms of the atmosphere and some sections of the Earth's crust. So this is going to form around 0.002% of the Earth's crust. So this is going to be a relative amount, and therefore that's going to be this specific quantity. So this is going to be approximately this specific amount. And of course, I've listed some of the sources apart from the atmosphere, where nitrogen is going to be found naturally. So it's going to be found in terms of compounds referred to as nitrates. And we can give an example of these specific compounds like salt, beta, and the nitrogen salt, beta. So this is going to be, so I hope my spellings are correct. And then we're going to see that it's going to be found as nitrogen, this is going to be sodium nitrate, and also it's going to be found in plants and animal proteins. And of course, we can as well find that it's going to be found in some of the different forms in terms of compounds, apart from the ones which we have mentioned on the board. And of course, this specific element is important in industrial processes, especially in the manufacture of ammonia, through the process that we refer to as the Haber process. Now we shall give a schematic diagram of this specific process, which we refer to the Haber process. This specific combination of the two gases is going to result in the formation of the gas which we are going to refer to as ammonia. And of course, I'm going to just give an illustration of this specific process in a different video, which we're going to use in understanding this specific characteristic better. So if you try to look at phosphorus in a summary form as well, we shall see that as given from my previous illustration, we're going to have some forms of allotropy, which is going to give us some forms of phosphorus. And of course, given in terms of white, the physical form, physical allotropy, so we're going to have white and red phosphorus. And the chief source of phosphorus is going to be phosphate roach. So this one is going to belong to a group known as aspartites, which are going to be, of course, forming the chief sources of this particular phosphorus. But in element form, this is going to be obtained by heating this specific form of compounds with silicon oxide and coke in an electric furnace. So if I may give an example of these particular forms of, so this is going to be a family of members referred to as aspartites. And if I may give an example of this one, we can have this one given in terms of that specific compound. So those are calcium, and then we shall have phosphorus given as such. So these are going to be 3, and then we shall have fluorine given as such. So this is going to be a larger family of members whom phosphate roach are going to be contained, and therefore we are going to obtain the specific forms of elemental phosphorus from this particular form. And I can just give a quick perhaps illustration of an example of how we can obtain that one in an equations form. So I've said that that one is going to be obtained from heating this particular phosphates with silicon oxide and of course a coke in an electric furnace. So we are going to have this stoichiometric equation giving this specific illustration. So we're going to have this one for 2. So this is going to be a solid. I've said that this one is going to be obtained by heating coke and silicon oxide. So this is going to be 6. And then we shall have, so the process of heating is going to result in the formation of calcium silicate. So this is going to be given in terms of 3. So plus 10 units of carbon oxide plus this is specific member of phosphorus for gaseous form. So these are going to be in terms of a solid coke, and then we are going to have this one in terms of a solid. So this is going to be gaseous. So if we look at this specific equation, this is going to be one of the ways in which we can obtain elemental phosphorus through heating this part of the phosphorus roach, phosphate roach, which are given in this specific form. And I said that this is going to form a wider, or just a member of the group of aspartites, which we are going to come across in some of our discussions. So in this case, phosphorus from this specific production is going to be condensed and collected and stored as white phosphorus. And this is going to be storage under water. Now, in some of our discussion on the laboratory procedures, we're going to see that phosphorus is going to be stored under water. And as I said, that basically this is going to be a white form of phosphorus. Now, phosphorus is an important element in our, of course, biological cycle. in a sense that it's going to be found in living organisms in form of deoxyribonucleic acid, which is a DNA, and in our bones and the teeth, which of course are going to form our support and structure, and of course one of the digestive parts of our accessory organs, which we're going to see being given in terms of our teeth. Now we're going to look at other forms of phosphorus which are going to be abundant, especially in the phosphoric acid, organophosphates, and phosphorus, which are going to form an essential part of our application, perhaps in industrial processes and in forms of living or in our biological processes, which are essential to support of life. Now, phosphorus as an element, a non-conductor of electricity, but it can ignite spontaneously, and of course, that's going to be one of its basic characteristic. Now, phosphorus, for which I've given in this particular case, is what are going to be molecules. Those basic structural units are going to be in molecular form, which I've said. So we can obtain red phosphorus through heating of a white phosphorus at 300 degrees centigrade Celsius, and then we're going to have a red phosphorus. So I've mentioned about allotropy. So we're going to physical allotropy of this specific element. So we're going to obtain that one from that specific case. Now, some of the characteristics of red phosphorus are going to include its comparison with the white one. It's going to be less reactive, and of course, it's going to be subliming at melting points of approximately 420 degrees. So in this case, we have talked about the concept of sublimation, and the sublimation is one of the properties of phosphorus which we are going to come across. And apart from this, it's going to have a triple point of 590 degrees Celsius. Now, applications of some of the compounds of phosphorus, like phosphorus chloride, this is going to find application in soap and detergent industry. So these are going to be detergents. So these are going to be some of the application in the plastic and synthesis of rubber, and of course in herbicides and insecticides, as some of the applications which we are going to be seeing being using this as phosphorus in terms of in forms of its various compounds. So kindly check our description boxes for various links of other videos. Now this video formed a summary of basically the group 5 elements, but we're going to come across other detailed forms of discussions on various reactions and uses as we come across them in our various videos. So that is it for now. Kindly check our description boxes and subscribe to our channel for more details on discussions in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.